Hello students, in the last video we have seen about address space allocation in IPv6. In this video we are going to see about how we are going to assign the private addressing in IPv6. There are two kinds of private addressing in IPv6. Actually those two are two blocks, unique local unicast and the link local address. Before going into the types, let me explain how the private addresses are used in IPv6. Suppose if I'm taking an internet service provider, ISP, or an private organization, which will be having many sub-networks like this. If a host from one network, from subnetwork 1, transmit the data to another subnetwork, but which is coming under the same ISP, we can use unique local unicast. Whereas if the node want to communicate within the same subnetwork, so this is called as a particular segment of network. So this category we have to use link local address. Whereas from one subnetwork to another subnetwork, but within the same ISP or within the same domain, we have to use unique local unicast. So this is the difference. First, let us have a look at unique local unicast. So in unique local unicast, it is used within an ISP domain. The 128-bit IPv6 address is divided into interface identifier for that 64-bit. So it is same like global unicast. Then subnetwork identifier, for that we have given another 16-bit. Then random number 40 bits. The first 7 bits, first 8 bits are the prefix. Let's look at the prefix. Do you remember what is the prefix we have used for global unicast? In global unicast, the prefix will be 001. In the case of unique local unicast, the prefix is 6 zeros. Okay, 6 zeros followed by 6 ones followed by 0. The next bit is called as a local bit. The local bit can be either 0 or 1, but mostly it is 1. Why? Because the system itself, the host itself is generating this unique local unicast. So it is locally generated. That's why we have given the number 1. If some global centralized authority is assigning the address, unique local unicast address, then we will be having 0, which is still reserved. So the 7 bits is the prefix, 6 ones followed by 10, and the next bit local bit, which is always 1. The next division is random number. Randomly 40-bit number will be generated. Since this random number generation is 40-bit, it is expected the number will be the unique number within the particular ISP. At least out of 40 bits, any one bit will be changing, so it becomes a unique number. Subnet identifier is the uh, particular subnet identifier number. Interface identifier number, it is generated based on EUI or from the existing physical address, like we have seen in the earlier video. So this is the packet format of unique local unicast address. The next one, link local address. Link local address, as we have seen, it is used for the host within the particular subnetwork. Okay. By having the link local address, a packet can't even reach the next subnetwork in the same ISP. So this is the case of link local address. Let us see the packet splitting of this. Like global unicast and unique local unicast will be having interface identifier, which is 64-bit. Subnet identifier will be there, and prefix and the remaining part. Here the prefix is 10-bit and the number is fixed 7 ones followed by 010. The first 10 bits are fixed ones, 7 number of ones, and 010, 10 bits. Remaining 38 bits, okay, we didn't give any specific field name. It should be 0. It must be 0. But in the case of unique local unicast, we are having some random number for this 40 bits. There is no such mechanism in link local. It should be 0. Subnetwork identifier also should be 0. Interface identifier, it can be derived from the existing physical address or from EUI number. So this is the link local address format. Thank you.